Force's Final iMovie by Silas Johnson, Winnetonka High School, Honors Physics. Force, definition and SI units. This slide shows the force definition and SI units table. Force is not a complex term, the definition of force is a push or pull. The SI units are below. Force, four fundamental forces, naming, describing, ranking by strength, and discussing why we are most aware of the weakest one. This is the picture of fundamental forces. Later on in the iMovie, the next slide will talk about the names will be different. Only weak interaction and strong interaction will be different. The four fundamental forces explanation. Gravitation is the weakest one, but it's very long-ranged. It is always attractive, and this acts between any two pieces of matter. Strong nucleus causes electric and magnetic effects, and is the strongest one. Weak nucleus, it has a very short range, and it means weak. Electromagnetic is electric and magnetic effects, and which is the second weakest. Contact and non-contact forces. These pictures show contact non-contact forces. Non-contact is on the right and contact is on the left. Definition of contact and non-contact force. When a force is applied on somebody by another object without any interaction or contact is called non-contact force. The definition of a contact force is where two objects interacting are touching each other. Types of forces. Pictures and examples of different types of forces. These pictures show they show a block, a ping pong ball floating on water, and Tigger getting hung by two pairs of strings, and me. And these are the force diagrams for each picture. This is the list of all the forces. Frictional force, gravitational, tension, electrical, normal, magnetic, air resistance, applied, and spring. Static equilibrium. Example of static equilibrium, a force diagram, and a description of the motion is what you'll be seeing in this next few slides. This is the picture of me holding down a spring. The F tension is on top, and the F applied, I am doing the F applied. Here's a description of static equilibrium. When the motion is at rest, it's static equilibrium. And when it means velocity equals 0. Dynamic equilibrium. These next few slides you'll be seeing examples, a force diagram, description of the motion, and a video clip. This is the force diagram for the last clip that played. It shows the F applied is going to the right, and the F gravity and the F normal are equaling out to each other. Here's an example of dynamic equilibrium. Disequilibrium. I'll be describing disequilibrium in the next slide. Description of disequilibrium. Disequilibrium is when velocity is changing. The object accelerates if forces are not balanced, and it's like pulling with a rope with a frictionless surface is disequilibrium. Mass, weight, and force due to gravity. Defining what they mean, how to find weight when you know mass, and discussing the definition of all three. Mass is the amount of matter in an object. Weight is a force on a mass by a gravitational field. Then force is a push or pull. I've said force is a push or pull earlier in the iMovie, and we're going to be describing it more. Finding mass, if you already know the weight, is you can solve it by an equation. And this is the equation by mass equals force due to gravity divided by gravity on Earth. The location of both weight and mass. Weight is related to the pull of the Earth or any other planet upon the stuff. Mass of an object, measured in kilograms, is the same no matter where it's at in the universe or like where it is. Effective mass on rate of descent of falling objects. Explaining if heavy objects fall faster than lighter objects and why a feather doesn't fall at the same rate of a rock. Do heavy things fall faster than light things? No, they don't. Gravity acts on all objects the same, so a feather and a hammer fall at the same rate and speed. If you dropped them at the same height, they would hit the ground at the exact same time. Why doesn't a feather and a rock fall at the same rate? They don't fall at the same rate because we have air resistance and wind resistance here on Earth, which slows the feather down more. Newton's law of gravitation. We're going to be stating the law, why the moon's gravitational field is weaker than the Earth's. The law of gravitation. The law of universal gravitation states that all objects with mass are attracted to all other objects with mass. So I'd be attracted to a pillow pet, or I'd be attracted to a sock, and I have gravity. The moon's gravitational field is weaker than the Earth's because Earth is bigger than the moon, so it's going to have a stronger gravitational field. The next slide gets in more depth, which answers the next question. Effect on gravitation. When a planet is 2 times as massive, objects in it will weigh twice as much, which explains why the moon is less has a lesser gravitational field than us. And this is it.